Good evening everyone, this is Harpreet. As a maths teacher, dear students, I hope you all are good and fine and completed the previous one work. Students, as you know, we have started the chapter number 8 as a trigonometry introduction to the trigonometry. Today we will discuss about the trigonometric identities. To discuss about the trigonometric identities, we will discuss what are the identities firstly. As into the previous classes we discussed, the identities are those which is true for, that is an equation which is true for all the variables which is used in that one equation. Okay, so here as trigonometric identities, an equation involving the trigonometry ratios of an angle is called the trigonometric identity. Okay, so let us see what are those identities. To show these one identities, firstly we will take as a right angle triangle. Let us take here a right angle triangle as ABC, where angle B is 90 degree. Here I am taking the angle C as angle theta. With respect of the angle theta, we will take all the trigonometry ratios. So this implies adjacent side we are calling as a base and opposite side we are calling as a perpendicular. By using the Pythagoras Theorem, we will show all the identities. The Pythagoras Theorem says to us as hypotenuse square is equal to perpendicular square plus base square. Now let us see here what is the hypotenuse. Hypotenuse, as you know, here is into the triangle. Here is the AC square is equal to. It is perpendicular, as we know that here we are taking the perpendicular AB plus BC as a base. So by each and every term divide by the each and every part as AC square, AB square and BC square. Then those trigonometry ratios involved, then we will say those are the identities. So firstly we will divide on the first number, divide by AC on both sides. So if we will divide it by the both sides as AC upon AC square we will divide it is equal to AB upon AC, its square, plus BC upon AC, its square. So on this side we are approaching as 1 is equal to. Now we have to see into the ratio about AB upon AC. AB is a perpendicular and AC is a hypotenuse. So perpendicular upon hypotenuse we are calling it as a, with respect to the theta angle, that is sine square theta, plus BC as a base, and upon hypotenuse, that is a hypotenuse, as here we will call it as a cos theta. So we approach the first identity. Here is sine square theta plus cos square theta is equal to 1. It is an equation involving the trigonometry ratios. So this is called as an identity which is true for all the thetas which are lying between 0 degree to as 90 degree. It is equal to 0 degree also and 90 degree. But confirm this one ki theta will be both angles. Here will be the same. As if we are taking as a 0 degree, then 0 sine square 0 plus cos square 0 is equal to always 1. Okay. Similarly, up to 90 degree we can take. Now let us see for the another part now. Same criteria again we will apply. AC square is equal to AB square plus BC square. Now we will divide by the base BC. Divide by, to make the another identity, divide by BC square by each and every part. So here will be AC upon BC whole square is equal to AB upon BC whole square plus BC upon BC its whole square. So we can see here AC upon BC. AC hypotenuse upon BC. Hypotenuse upon base is the reciprocal of the cos, and cos reciprocal we are calling as a secant. It is secant square theta is equal to AB upon BC perpendicular upon base, which is equal to tan. So we are writing here tan square theta and it is equal to 1. So we approach here the first identity as secant square theta is equal to tan square theta plus 1. Okay, so which is true for all the thetas but less than 90 degree only and greater than equal to 0 degree. Why we are not taking equality of the 90? Because we know that the tan theta is not defined for the 90 degree angle. So that's why we are taking as 0 degree to 90 degree but less than 90 degree only, not equal to 90 degree. Fine. So let us see now the another part. Last part. AC square is equal to AB square plus BC square. Now what is here, we have to divide by each and every part by the AB. So AC upon AB whole square is equal to AB upon AB whole square and plus BC upon AB whole square. So into the diagram we can see AC upon AB, which is equal to hypotenuse upon perpendicular. It is the reciprocal of the sine. So sine reciprocal is cosecant. So we can write here cosecant theta is equal to 1 plus BC upon AB. Base upon perpendicular, reciprocal of tan. Tan reciprocal we are calling as cot square theta. So we approach the third identity as cosecant square theta is equal to 1 plus cot square theta, where theta is always lies between 0 degree to 90 degree. Here 0 degree not equality, but 90 degree there is equality. As we know that cot square theta is not lying for the 0 degree. There is undefined value for the cot theta as 0 degree angle. So that's why it is not equal to the 0 degree but equal to the 90 degree and between these two angles. Okay, so these three identities we approach here as first one is sine square theta plus cos square theta is equal to 1. Secant square theta is equal to 1 plus tan square theta or tan square theta plus 1. And third one is cosecant square theta is equal to 1 plus cot square theta. So these are the three identities. Let us see now how to use these one into the question. So you can see here the first one question into the 8.4 exercise. First one, they are saying that show that sine A, secant A and tan A represent into the cot A by using these identities. So let us use here. As we know that sine A, we have to represent into the cot A. Sine A is reciprocal of cosecant, and there is an identity between the cosecant and cot. As we know that cosecant square A is equal to 1 plus cot square A. So we can approach here as here will be the cosecant square A, cosecant as A, there will be square root of 1 plus cot square A. There will be plus and minus, but we will take only the positive value. As we know the thetas or the angles are always lies as a positive value for the 0 degree to 90 degree. Okay, so that's why we are taking only the positive value. So we can write here sine A is equal to 1 upon into the square root 1 plus cot square A. So sine A is represented into the cot A value. Okay, so let us see now the tan A value. We know that tan A is the reciprocal of the cot, so easily we can represent it 1 upon cot A, that is also represented. Now for the secant A is left, and we know that the relation between the secant and tan A with respect to the identity, that is secant square A is equal to 1 plus tan square A. So we can write here the square root of it. So we will write here the secant A is equal to the square root of 1 plus tan square A, which is equal to into the square root 1 plus tan value is 1 upon cot square A. If we will solve it into the square root cot square A, there is cot square A plus 1. Then into the square root, it is cot square A plus 1, and into the denominator it is square and square root. Then denominator only cot A is left. That is the answer. So we represented the secant A value as like as this. Okay, so we represented all these t ratio which they are demanding into the form of the cot A by using the identities. By using these identities, you can try the another question related to the 8.4 exercise, students. And if any query, then into the Zoom session we will discuss. And thank you. Have a nice day.